step function, also called the greatest integer function, okay? There is a button on your calculator. I'll show it to you in 1 minute, but I want to show you what the actual notation, the parent function is. F of x equals, it's this weird looking bracket. It's got like almost like a double bar bracket around it, okay? When you see this, I hate this phrase greatest integer function, but I want to show you that phrase because that kind of implies something that I want to do mathematically that is not correct. This step function is what I call it because when you see this, what this bracket means is you need to round down. Round down. Greatest integer implies I want to round up. That's why I hate calling it the greatest integer. I like calling it step function better. So let me give you just some quick examples without using your calculator, then I'll show you where it is in the calculator. F of 2.7, F of 0.5, F of negative 3.4. So round this down. It's odd because we always are used to rounding up. Since elementary school, we've rounded up. Oh, if it's bigger than 5, we round up. Don't think like that. No matter what, round down to the next integer. What is the next integer rounded down to 2.7? 2. What is the next integer rounded down from 0.5? 0. Careful. What is the next integer rounded down to negative 3.4? There's always somebody that says it. Negative 4. Rounding down negative 3.4 would go to negative 4. Okay? Now, in your calculator, it is located under Math Num Int. Math Num Int in your calculator. So if you are to graph this right now and you go to y equals and you hit Math Num Int, then put x, close the bracket or the parenthesis, zoom 6. It looks like a step because it's a bunch of pieces, a bunch of steps. Yeah. Okay. Now, on one of those sides, though, it is closed, and the other side, it's open. If you're using a calculator and you hit trace right now, when you hit trace, the calculator will automatically try to find a closed dot. So I know that this step function is closed on the left, but open on the right, just by hitting trace. Trace will always help. The calculator will try to find a dot, a point on the graph. So if I were to graph this, I would have a closed dot, a line, and then an open. And it's very hard, of course, with my marker here, and it would just continue that pattern. Closed, open, closed, open. But something really interesting here, again, if you're familiar with lines, think of this as y equals x, the y equals x line, okay? And I'll show you why in a minute because we'll do a transformation in 1 minute. But y equals x means that you start at 0, 0. Would you agree? And then what direction do you go? Up 1 over 1, correct? Up 1 over 1, up 1 over 1. You are actually graphing all the dots like that. So you would actually know what this graph looks like if you just graphed it as a y equals. Let me give you another example. So that way maybe it'll make more sense to this second one. F of x equals 2 times the greatest integer of x minus 5. So a shift has occurred. Again, thinking back to when we did transformations. What does that minus 5 do to the graph? What's it going to do? Down 5. What does a 2 on the outside do to a graph? it makes it kind of a little bit more skinnier, I guess. Or yeah, this is where the verbiage affects me because I don't like saying compressing, expanding, whatever. So here's what's really neat about it. So look at it like this: y equals 2x minus 5. And you would go to where on your graph? -5, right? 2, 4, -5. You would go up to over 1. Up to over 1. Well, what you're graphing right now are the steps. Then you just make a line, open circle, line, open circle, line, open circle. You've just made a more slanted looking step function. That's really all that happened there. And you can look in your graph y equals right now 2 times integer x minus 5, just to show you. It's just a little bit more slanted right now. Again, if you hit trace, it'll send you to the closed dot. All right, so we're gonna just practice this with this worksheet that I've given you. I want you to just do the front page real quick. Don't do number 1. We don't need to. And then after this, we're just going to give you an outline for the quiz tomorrow. Well, actually, I got to do the word problem on the back. Very easy. Sorry. Round 5.7 down, you should have 5. Round 3 pi down. 3 pi is actually 9 point something, so it rounds down to 9. 0.2 rounds down to 0. For this one, where it's 2 is on the outside and then the square root of 5 is inside, you actually find the greatest integer of this first. The greatest integer of the square root of 5 is 2, and then 2 times 2 is 4. Okay? Negative 6.1, what does that round down to? Be careful. Negative 7. And then 5 times negative 9.1, greatest integer. This, again, greatest integer would actually be negative 10 times 5 is negative 50. So that's that one. Yeah, I know. All right. Then for this part, you were just asked to sketch in a certain domain. I'm just going to graph pretty much as I can. But again, this is the y equals x line. So I know it starts at 0, up 1, over 1, up 1, over 1. They want you to go to 4. Is that right? Whoops, up 1, over 1. So this is what you would graph. And then you just keep the pattern going down up until negative 4. But I think you get the gist. For this one, this is the y equals 3x line. So again, through 0, 0, this time your slope is up 3, 1, 2, 3 over 1. Up 3, 1, 2, 3 over 1. And then you draw your steps. Or down 3, 1, 2, 3 over 1. And then obviously keep it going one more. For this one, you would have, I'm going to rewrite it. Y equals negative x plus 2. Right? Isn't that what that is? So start at 2. And then I would go down 1, right 1. Down 1, right 1. Down 1, right 1. Actually, this one wants to go from 0 to 5, so I won't go up. And then this is where you would draw your piece, your step function. Pretty easy. Like I said, not going to see it on the quiz tomorrow, but you will see it in a minute. Just a little word problem here, just so you can understand when it's used. You are selling candy bars. The taxable amount and tax imposed up to $1 are shown below. For amounts that are between 1 cent and 20 cents, the tax is 1 cent. For amounts greater than 20 cents, less than or equal to 40 cents, the tax is 2 cents, etc., etc. Let's complete the graph of the tax imposed on the candy bars. So this second sentence is actually showing me that the less than or equal to is on the 40 cents, not the 20 cents. Do you notice that part right there? So when I go to graph this, from 20 cents it would be actually open to 40 cents closed. So that way, when I do this first sentence, I'm going to do the same thing, open, closed. Okay, draw that step function for me right there. Finish drawing that for me. Oh, Mrs. said I already drew it wrong. Boom. And this is what I was just talking before about. This is, step functions are really used in taxes a lot. They're used in like post office when you go to mail packages. You have the same amount of tax as long as you're within buying something from 0 to 20 cents. You have the same amount of tax. When you do your taxes at the end of the year, you're in the same tax bracket. So if you could answer 7, 8, and 9 right now, a candy bar costs 55 cents. What would be the total cost with tax? Which would be 58 cents. That would be the total cost. Okay. Your aunt purchased 3 candy bars at 55 cents a piece. What is the total cost with tax? So now what would we do?
Wait, is it per bar? Or is it every single bar?
Per bar. So you would have 3 cents, 3 cents, 3 cents, which is really how much? 9 cents of tax.
$1.
But you had 55, 55, 55 in terms of buying the candy bar. So you just multiply that by 3 and add the 9 cents. What did somebody say it was? $1 what? 174. Okay, then you can answer this last question. Someone purchased 4 candy bars. First question on the quiz tomorrow will be, identify where this function is increasing or decreasing. Remember, you should start everything in intervals, starting at negative infinity. Your intervals are along the x-axis. They are not y values at all. Don't you dare give me a y value. Okay? So right now, what is my pen doing? Is it increasing or is it decreasing?
Decrease.
Up until about here, would you agree? Find out on the x. I'm going to pretend it's right there. Where on the x is that? Well, that would be -4. So you'll say it's decreasing, Mrs. Seta, from negative infinity to -4. That's it. Then my pen starts to increase again, correct?
Yeah.
Up until, would you agree about here? Again, bear with my drawing. We're going to pretend it's there. So I would say it's increasing on the interval from wherever you left off, -4, to where on the x? 0. Not 2. Don't give me a y. Give me an x. Then my pen is decreasing again. From where to where? 0 to infinity. Now, here's the problem. A lot of students think it's pointing down. So, like, shouldn't I write negative infinity? No. We're talking about the x-axis here. The x-axis gets larger as you go to the right. So that's the first part of the homework tomorrow. 3 questions like that, or, well, 1 question, I would say. I'll give you 1 graph. You'll have to tell me where it's decreasing or increasing. Easy stuff. Second thing, classify and name extrema. Okay, I will give you a function, and you will go in your calculator, because I will let you use the calculator for this part, and you will do that famous phrase, second calc, not 5. Second calc, what? What are extremas? Max or min. And then you'll be asked, left bound, right bound, guess. And so let the calculator do that work for you. And then just write it out. That's it. Go how many decimal places? Go to 1 or 2 decimal places. Very easy. I'm not going to do that one right now, but I'm going to use that example for the next one, which is finding the average rate of change. I will give you a function. I'm going to use the same function. I will also have to give you an interval. Average rate of change, remember, is just a fancy name for saying slope of the secant line. Find your slope. That's all that means. Find a slope. So the way that you do that is you plug these values in, and you can let your calculator really do all the work because your calculator has a table in it, does it not? So you find 2 in the table and you find 5 in the table. When you plug 2 into that function, it'll tell you I'm going to kind of tell you, yes, 16, I'm going to cheat it. And then this is 175. And then you just do slope, y2 minus y1 over x2 minus x1. Slope, 175 minus 16 over 5 minus 2. And you get 159 over 3, which is 53. That's it. That's all you have to do. Find the slope. Okay? All right. Last part of the quiz. You are not allowed a calculator for. Sorry. No calculator. Boo. You will have 4 transformations. I will give you 4 different equations. I'll give you 2 right now. And you will tell me what transformation has occurred. But you can't use a calculator for it. Okay, so looking at this equation right here, you are telling me what transformation has occurred from its parent. So the parent would be x squared. What does the minus 2 with the parent tell me I went? Right 2. What does the minus 6 on the outside say? Down 6. That's all you would say. That's all you put on the line. What transformation occurred? Okay. Yes, Liam.
Is there going to
up 7. What does that negative do? Flips it actually over the x-axis, but you can just say flips. It again, what I was just saying with Liam, if there was a 1/2 here, you would just be like, oh, I know it just, that 1/2 makes it get wider, as opposed to if there was a 2 and it makes it get skinnier. So you could just do that. You will have one question where you need to write an equation out for me, and I will give you the parent and the shift, and you will write the equation. So what I mean is I'll say something like, absolute value is your parent, and you went down 3, left 2. So could you write an equation for me that has absolute value parent in it, and it goes down 3, left 2? And what would you say? Absolute value, x plus 2, because that would be the left, and then minus 3. That's it. That's one question like that. Okay? And I'm not going to do it for you, but the big one on this test is graphing a piecewise. You will have one of them. It will be a 3-piece. You really, really, really need to be accurate about your points. What I mean is the following. You can write this down if you want to be accurate with points on the graph. Because this is what I did last year. I took off for that. A lot of students would, oh, sorry about that. They go like this. And be like, oh, look, it's a parabola. But really, it should have been a little bit more skinnier. See what I'm saying? So you really would want to find another point to be more accurate on. That's where I think the tables kind of help out a little bit more than the erasing does. But, you know, some of you could probably find that very easily. But that's it. There's your homework. That's the whole entire lovely thing. All right. So I'll let you start right now. Homework. And